Hello grade 10, how are you today? I hope you're doing fine. In this video, I'm going to talk about electrical circuits. It's going to be the last topic for dynamic electricity, okay? But because this one is a little hard, we are going to discuss in two parts. So this video is going to be the part A, and then after we're going to do part B. Okay, so let's go. Electrical circuit. Electrical circuit is a network in which electrical charges can flow continuously in a loop. So is any network that allow the charge to be flowing without interruption. Okay, so for example, here I have a battery that's connected to for example, a switch that we can turn on and turn off to turn on the light. In this circuit, we have three main components that are essential for this to work. The first one is the power supply. So it depends, can be a battery, can be a generator, okay, depends on which power supplies you use. But important that this power supply creates a potential difference, okay? Remember that you measure in volts. If you have no idea what I'm talking about, please refer back to the previous videos where I talk about potential difference, okay? So power supply in this case, for example, is the battery. So the battery is the power supply and it provides a potential difference that I measure in volts. Potential difference is the same as voltage that we measure in volts. Another component is my element, in this case is my light bulb. This element uses the electrical energy and makes some resistance to the electricity to flow. Okay, so when it goes here, it turns on, but it's also a resistance for the current to flow. And this resistance we measure in ohms. So the light bulb is the element that provides some resistance to the current flow, and it measures in ohms. I also have a class about this one only, so please refer back. And the wires is that they carry on the electrons, the flow of electrons. So it carries on the current intensity, and we measure it in amperes. Okay, so the wires is from where the electricity flows, connecting all the elements, connect the power supply to the resistance, for example. If you don't know, please, I have a video about each of them: potential difference, resistance, and current intensity. Refer them back and come back to this one later. Are gonna be completely lost, okay? Okay, so the three components of electrical circuit are power supply, in this case a battery, my element, in this case my light bulb, and my charge, in this case that I'm using wires to flow. I have some ways to represent an electrical circuit. To represent that, we use specific symbols. So here you don't need to memorize, just be aware that they exist, okay? Here is a representation of an open switch, and this is closed switch. So if this is open, it's representing an open switch. It means that it's not turned on. And if it's closed, it means it's turned on. And a fuse, we also have a video about this, is this representation. The battery, you can represent like that or like that, okay, it's the same. The voltmeter, when I want to measure the voltage. The ammeter, when I want to measure the current intensity. The buzzer, when I need to connect. The lamp or the bulb, I can use these two symbols. And the resistor, you can find this symbol or the other one. The most common is this one, and I'm gonna use this one, okay? So you're gonna see this one a lot. This is the most important symbol that you need to recognize. You're gonna use a lot. So just to be aware, because in books, in the internet, you can find different symbols. You don't need to memorize, just for you to be aware they exist. And here I'm gonna show you three models of electric circuit, because there is different kind of representations, and I want to show you different models for you to not get confused, okay? But they all do the same. In this model here, I have the resistor, okay, as I said, is the most important. the ammeter that is measuring my current intensity, and my battery. This is the simplest one. Okay, so my battery, my potential difference with this symbol here, my resistor with this symbol, and my ammeter representing the current intensity with this symbol. Another model. Here, for example, the battery, you can also find it with the charge, positive and negative. And remember, the conventional flow goes from positive to negative, and the correct flow, electrical current flow, is the negative to positive. And the lamp, as in the picture here, you can represent with the symbol. There are two symbols, but here they choose this one. And the switch, just the same. Okay, so it's another representation you can look. And the third one, here a little bit more complex, because now I don't have just one battery, but three. So if I have three batteries, I need to represent as three symbols connected. Okay, the resistor is the same, the light bulb is the same, and the switch. And I can also represent the light bulb as a resistor, because they act as a resistor. Okay, so you can find separated or two as a resistor. The two are correct. So just be aware of this representation. Okay, when a circuit contains two or more elements, the components can be connected in different ways. There are two main ways that I can connect all the circuit or the elements. I'm going to focus on the elements in this class. Here I'm representing the resistor. I have 1, 2, 3 resistors. They are side by side. When they are side by side in a single line, I say they are in series. So it's a series circuit. It's a circuit in which the elements are connected end to end. So if I, for example, follow the line, I'm going to put another column. If I follow the line, they are all connected in the same line. Okay, so they are in series. And the other way is in parallel. So in parallel circuit, what's happening here? They are not side by side, but they are parallel. The circuit that contains at least one branch. So the current comes here and divide, comes one over here and then continue, another come here and then continue and come here. So they are not connect in series, they are connecting parallel. They are in parallel, okay? And they have different nodes. I'm gonna talk about nodes soon, but they are connected to different nodes. So these two nodes here, these two here, this one here, and this one here. In the series, I have just two nodes that are common to all of them. That's why they are in series. Let's talk about the series circuit first. Series circuit is a circuit in which the elements are connected end to end. So they are connected end to end in a single line. So here I start, for example, this battery is connected three lights. And these lights are connected in the same line. Okay, so I come from positive and I go in just one direction. For example, the current flows in one direction only. So in series circuits, the circuit has no branch out at any point. So the current can flow only one path. So current flow only one path. If one of the circuit components is defective, the entire circuit stops because the charge will no longer flow. So if I break here, for example, none of the lights will turn on because I interrupt all the current for all of them. Okay, or the same, if I interrupt here, it's gonna cut for everybody because I broke the circuit. And the amount of energy available for each resistor is reduced if more resistors are added up. So it's like they share the same current. So if I put more resistor, I'm gonna have less energy for each of them. This is the example of Christmas tree lights, for example. I usually connect in series. So if you for example, put all of them side by side, you're gonna see they are connected by one single wire. But let's take a look in parallel circuit. They are not connected end by end. So see here, I also have 3 lights as example, but they are not connected in one single line. So I have one come here, then I have this branch, then I have another one come here, another branch, and then another one come here, another branch. In these parallel circuits, I call these intersections as nodes. Okay, so we have different nodes, not just 2. So each resistor is connected to 2 different nodes. But there is an advantage, because if one of the circuit components is defective, the elements on the other branches can continue flowing. Okay, so let's say if I cut this part here, the other 2 are not, for example, are not damaged. They continue to work. The same, if I cut this one here, the other 2 continue to receive the energy. Okay, it's not gonna break because it's gonna continue the circuit for the others. The effect on each resistor is shared among the various pathways. The total resistance drops instead of increase as resistors are added. So the total resistance drops instead of increasing as resistors are added. So if I put more resistors, I'm gonna have less total resistance. And the current density is shared among the various resistors. The circuit branch out at least once and the current flow different paths. So it means the current doesn't flow just one path, but different, because it goes, for example, for the first one, then goes another one and another one. It's not just one direction for all of them together. The points in which a circuit separates are called nodes. So nodes is where the current shares is split, okay? To do some calculation about this, we use 2 main laws that we call Krishna Laws. The first law says the intensity of a current that flows into an element or node of an electric circuit is always equals to the intensity of the current that flows to the element. So the intensity of a current that flows into an element or node is always equals to the intensity of current that flows out of that element. So the current that comes in goes out of the circuit or not. The second law, the total energy acquired by the charge from the power supply is always equals to the total energy transferred by this charge, whatever path they may take in the circuit. So the total energy is always equal to the total energy transferred by each of that charge, whatever pathway they make it in the circuit. So the energy that the charge take is always equal in the whole circuit. Okay, so I'm gonna use this to make some calculation, okay? So let's compare the electric current in a circuit to a fleet of trucks delivering goods along a particular route. So I'm gonna do an example to make this more clear. So let's say I have, for example, a factory that is delivering some goods. Then they use a truck to deliver. Let's say I have more than one truck. So the number of trucks that I have per minute in that road would be, for example, my current intensity, okay? The number of boxes a truck is transporting is the electrical potential, or the volts. No, not the volts, sorry, the electrical potential, how much they can be transported. The potential difference V is the difference between the number of boxes a truck is transporting before and after a delivery. So potential difference, remember, is a difference between the before and the after. And the resistance is the measurement specific to each customer. For example, the customer decides how many boxes to take from each truck. So let's see a picture to make this more clear. So for example, this is an example of a series circuit. What's happening here? Here's the factory. So I have 4 trucks, the green, the yellow, the blue, and the red, okay? Here, in this path, I have 4 trucks per minute. This is the current, okay? And each truck is carrying 12 boxes. So it's the capacity of each truck. When it goes to customer 1, each of them has delivered 6 boxes. So they start with 12. After they pass into the customer 1, altogether, each truck delivered 6 boxes. I also continue to have 4 trucks per minute, but now with less box inside because it delivered 6 boxes. After that, it goes to customer 2. What happened then? They delivered 3 boxes. So here now, each of them delivered 3 boxes. Now they have 3 boxes in each of them. But I continue having 4 trucks per minute. Then they go to customer 3 and deliver all the 3 boxes they have. So they come back to the factory with no boxes at all. What didn't change here? In this series secret, I didn't change the number of trucks per minute, or I didn't change my current intensity because my velocity is the same, trucks per minute. So I can see over here? What's my current or the number of trucks per minute that I have in the first one, the first customer? 4 trucks per minute. In the second customer, also 4 trucks per minute. In the third one, also 4 trucks per minute. So what I conclude? The current intensity is all the same in the whole secret. So a total is equal to E1, I1, I2, and I3. What about the potential difference? Are they the same? So when the trucks pass from customer 1, from the factory, when they go wait to the customer 1, they delivered 6. So they delivered 6 boxes per truck. So each truck delivered 6. In the customer 2, they delivered 3. Remember, it was 6 and now they have just 3. So they delivered 3. And from 2 to 3, they also delivered 3. Okay, in this example, so they also delivered 3. What can I conclude here? Before, I have 12 in each, right? After each of them delivered, I have 0, of course. But how much I delivered? I delivered 6 first, then 3, then 3. 6 plus 3 plus 3 is equals to 12. So my V total is the sum of my V partial, V1, V2, and V3. They are not equal, but now they are the sum because it's the capacity, how much they delivered. It's the potential difference. Remember, the potential difference is how much I had before, how much I have after. This is the difference. So the potential difference is the sum, and the current intensity are all the same. Let's see now the parallel circuit. What happens when I have a parallel circuit? So all the trucks the same way, they start in the same way. 4 trucks per minute, 12 boxes in each truck. What happened? They left the factory together. But when they came here in this intersection, they split. 2 trucks came to the customer 1, that is this pattern, and the other continues. So the blue and the red came here to deliver to customer 1, and the yellow went to the customer 2, and the green went to the customer 3. So they follow different paths. Okay, what happened when the truck yellow and blue came here? So when they came to the customer 1, they delivered all the 12. So they delivered all the 12 just to customer 1. When the yellow truck delivered to customer 2, they also delivered all the 12. So they came back with 0. And the green one, the green also delivered the 12. So they came back also with 0. What I can conclude? The current intensity now is the same in all paths. So let's observe the first path. For yellow and for customer 1, how many trucks I had? 2, right? So 2 trucks per minute. So my current one is 2 trucks per minute. How many I have for customer 2? Just 1, right? 1 truck per minute. And how many I have for customer 3? Just 1 truck. But in total, how many trucks I have? 4. So my current now is split, but my total is continuing to be the same. So for me to calculate the E total, I need to add I1, I2, and I3. Okay, now it's not the same because they follow different paths. What now about potential difference? In the customer 1, what happened before and after? So before they have 12, after they have 0. So what's the potential difference? 12, right? Because they have 12 minus 0, 12. So the voltage 1 is 12 volts per truck. The voltage 2, they have 12 before, and now they came back with 0, also 12. And 3, they came with 12, came back with 12, so also 12. What I can conclude? That my voltage total is the same. I start with 12 box in each truck, and I finish with 12 box in each truck. So my potential difference was 12 for all the sequence. So V1 equals to V2 equals to V3. Okay? This example for trucks is exactly the same for current, but instead of number of trucks, is my current intensity that I measure in amperes. Instead of number of box, I have my voltage, okay? And my resistance would be the customer. So let's do an example here. So here I have like a more real circuit. This is a series. How do I know? Because I come back and I have just one single line that connects all of them, okay? So if I have just one single line to connect all of them, is a series circuit. So here, current intensity. I know that for series sequence, the I total, the current intensity, is the same in all paths because I have just one path. So from positive to negative in conventional current. So all the path is the same current intensity. What about the potential difference? Remember, the potential difference in each of them is the sum. So the potential difference, the V total is equal V2, V1, so sorry, this one is 1, V2, V1, and V3. So when I add V1, V2, and V3. Now, what about the parallel circuit? The parallel circuit, if I try to make a single line, I don't have a single line connect all of them. I have this single line here. So let's say go to the V3. I'm gonna put another color, for example, green. I have this single line here connecting the two. And then I have another one. Another one, come here, 2, 1. So I have 3 paths. If I have 3 paths, I have 3 different currents. The current is split. So my E total is gonna be the sum of my current, I1 plus I2 plus I3. And the potential difference. The potential difference is gonna be the same because it doesn't split, okay? So remember, I split, but my potential difference keeps the same. So my potential difference is gonna be V1 equals V2 equals V3, okay? Now, how do I calculate equivalent resistance? Because I can have different resistance. For me to do calculation, I need to find just one. So equivalent resistance is the amount of resistance needed in a single resistor to replace the entire collection of resistors in a circuit. It can be calculated using Ohm's law and Kirchhoff's law. So I'm going to show you here, but you don't have to do this, okay? Just for me to show where the formula comes from. So let's say in series circuit, I know the current is all the same for all, and the voltage is the sum. And just remember the Ohm's law from the previous video, V equals R times I. Here I can, for example, R times I can put here, okay, as the total, and is equal to the sum of each of them. So I'm going to put resistor 1 times current 1, resistor 2 times current 2, and resistor 3 times current 3. But I know in a series secret, the current intensity is all the same. So I'm gonna replace the I by just I because they are all the same. Okay? And if I simplify this by dividing everything by I get my resistance total is the sum of my resistors. Okay? R1 plus R2 plus R3. Okay? Keep that for now. You don't need to do this calculation. Okay? I'm just showing where this comes from. Parallel circuit. In parallel circuit, I have my current as a sum of each of them. And my voltage was equal to all of them. I'm gonna apply Ohm's law, but I'm gonna arrange a little bit because I is gonna be V divided by R. So I'm gonna put V total divided by R equals V1 divided by R2, V2 divided by R2, V3 divided by R3. Because the voltage is all the same, I'm gonna replace all the V's by just V. And I'm gonna simplify divide by V. I'm gonna not do all the math, okay? But if I divide all by V, I'm gonna get 1 over equivalent resistance equals 1 over resistance 1 plus 1 over resistance 2 plus 1 over resistance 3. So this is gonna be the resistance equivalent by for parallel circuit. So for series circuits, you just add. For the parallel circuit, you need to invert all of them before adding. Okay? You just need to know the formula. You need to know how to use it. Okay? And you don't need to do this math. I'm just showing you where this comes from. But you need to know that you need to use this formula. Okay? So in summary, okay, so this is the main information you need to know for you to do the exercise, okay? I'm gonna do the exercise in another video. So in summary, my current intensity in series circuit, they are all the same. In parallel circuit, they are the sum. My potential difference in series circuit, they are the sum. In the parallel circuit, they are the same. My equivalent resistance in the series circuit is the sum of each of them. In the parallel circuit is the inverse. So you need to inverse them before sum. Okay? So this you need to know, at least you need to look at it, this chart, and understand what is telling you. Okay? Okay, guys, so in the next video, I'm gonna do the practical exercise, okay? But it's really important that you understand this one first, okay? So that's it. Thank you so much for watching.